Hello students, today we will be continuing with the previous chapter, that is laws of motion. In the last video we have discussed about force and its type. Now we will be moving to different terms that we will be learning so that it will help us to understand the laws of motion more easily. The first term that we will be learning about is inertia. What is inertia? It is the property of an object by virtue of which it tends to retain its state of rest or of motion. So, what is inertia? It is a property of a body. Like if a body is in a state of rest, it will try to stay in the state of rest, and if it is in state of motion, it will continue to be in motion with the same speed and it will move in the same direction until an external force is applied on it. Now, inertia is also of two types. First is inertia of rest, second is inertia of motion. Inertia of rest is if a body is at rest, it will remain at rest unless an external force is applied to change its state of rest. And inertia of motion is nothing but if a body is in the state of motion, it will continue to be in the state of motion with the same speed in the same direction in a straight line unless an external force is applied on it. That is, it is not only it will continue to move, but it will move with the same speed as well and in the same direction. Now, inertia and mass are related to each other. Why is this property of inertia? The property of inertia is because of mass of the body. Each body has mass, so larger the mass, larger is the inertia of the body. That is, mass and inertia are directly proportional to each other. Like if a mass of a body is more, then you will need more force to change its state of rest or motion. Next term is linear momentum. Now suppose two bodies are moving. Okay, two bodies of different masses are moving. So the force required to stop the body which is heavier will be more than the force required to stop the body which is lighter. Same way, if two bodies of same masses are moving but with different velocities, the body moving with larger velocity will require larger force to stop. So linear momentum is nothing but the product of the mass and velocity of that body. It is also termed as momentum and it is denoted by the letter small p. Its SI unit is kg meter per second and it is a vector quantity. That is, it has magnitude as well as direction. Now change in momentum. What is change in momentum? Final momentum minus initial momentum. How to find the final momentum? See, mass remains the same. If mass is the m is the mass of the body, v is its final velocity and u the initial velocity, then m into v will be the final momentum and m into u will be the initial momentum. And if we find their difference, that is the change in momentum. Next is rate of change of momentum. What is rate of change of momentum? Change in momentum with time. That is mv minus mu by t. Now if I take m as common, there will be v minus u by t. Now v minus u by t is acceleration. So rate of change of momentum is the product of mass and acceleration of the body. Okay. Now we will be moving to Newton's laws of motion. There are three laws of motions. The first law says that if a body is in a state of rest, it will remain in the state of rest, and if it is in the state of motion, it will remain moving in the same direction with the same speed unless an external force is applied on it. That is, it maintains the inertia. We have discussed about inertia, that is the property of inertia is being maintained by a body, that is being said in the first law of motion. Now this first law of motion defines force qualitatively. Like, what is the quality of force? Like, it will, until and unless you are applying a force, the state of rest or motion of a body, it remains unchanged. The next law, that is the second law of motion, is the rate of change of momentum of a body. I have told you what is rate of change of momentum, is directly proportional to the force applied. That is, the change of momentum will increase with the increase of the force, is directly proportional to the force applied on it, and the change in momentum takes place in the direction in which the force is applied. Rate of change of momentum is a vector quantity. So what is its direction? It is in the same direction as the force which is being applied on it. Now this law defines force quantitatively. See here, rate of change of momentum is directly proportional to force. That is, force is equal to rate of change of momentum. Now the last law, that is the Newton's third law of motion. To every action there is always an equal and opposite reaction. Like, for an example, if you are trying to push a wall, you are unable to push it. Why? Because the wall is also pushing, means not pushing actually, it is also applying an equal force but in the opposite direction. Now this Newton's third law of motion explains how the force acts on the object. Like, if the force is acting in one particular direction, the reaction force is acting on the opposite direction. And students, make sure if you are writing the laws of motion, don't change the words. Laws are universal, so you have to write it accordingly. Means the statements should be complete and the main word should be there. If you skip any of the part, you are not going to get any marks. So make sure you are writing the laws properly. Learn the laws, write it, practice it so that it comes to an habit and it won't be tough for you people to write during the exams. So in your book you will be finding few examples related to these laws. Go through those examples. They can come in give reasonings and all. I will be giving you questions in the worksheet related to the examples of this laws, and you will be able to understand the application of different laws in our daily life.